it's time to take a look at what the graphs of sine and cosine look like. So we're going to pull a few things that we've had from lectures in the past back up on the board here. Kind of the idea of our unit circle from our last lecture, and just the unit circle with just the coordinate points from a couple of lectures ago that we're going to need real quick. So the question is, if we started out with something like this, let's do y is equal to the sine of theta, or whatever letter you want to use. You can use y equals sine of x or t or whatever. If we said to graph this function, how would we do that? Well, anytime you need to graph something and you have no idea how to graph it, one method would be just to make a table of values. So that's what we're actually going to do here. Now I'm going to pick angles to plug into the sine function. So to do this, let's pick angles that we actually know a little bit about. Now, because I have this picture over here, let's just use our quadrant angles. 0, pi over 2, pi. Of course, this down here is 3 pi over 2 and back around to 2 pi. I hope that 2 pi is actually in frame there. All right, if we make it all the way around, so let's put those on here. We have 0, pi over 2, pi, 3 pi over 2, and then back around to 2 pi. Now remember, when we're on our unit circle, either if you're using the full picture or just the coordinate, our quadrant angles like this, the sine is the y value of each point. So the sine of the angle 0, that's when we're looking straight down the positive x-axis, the y value of that point is 0. If the angle is pi over 2, which means we're looking straight up, the y value of that point would be 1. Let's see, as we look down the negative x-axis, so we're looking towards pi down here, the y value of that point is 0. At 3 pi over 2, we're looking straight down, the y value of that point straight down would be -1. And then we make it back around to 2 pi, of course that's going to have the same answer that we started with. So let's kind of draw our picture here. I can see that our angle starts at 0, it's getting bigger, so I'm going to kind of draw my coordinate system kind of skewed over this way a little bit since these are all positives. Now I have 5 things here, so let's just go ahead and space these out kind of nice. So here we'd have 0 where we start at, pi over 2, pi, 3 pi over 2, and 2 pi. So there's all my steps, at least all the ones I'm putting in. Now we kind of should have already known this from the last lecture when we talked about domain and range. I know the range of sine, the answers we can get out. The biggest it can be is 1, the smallest it can be is -1. So on this axis, this would be our y-axis. I'm going to put values of 1 and -1. Of course, these are our angles. So our first point is when our angle is 0, the y value is 0, so we get that point right there. When we're pi over 2, we're up here at 1. At pi, we're back at 0. 3 pi over 2, we're at -1, and at 2 pi, we're back around, we're back to 0. All right, so we have 5 points here, but the question is, how do we connect the points? Well, here we got to kind of visually picture what it looks like as we go around our unit circle, right? When we started our point 0, 0 here, as we go around our circles, our y values slowly get bigger until we get up to 1. So the idea here is they're slowly getting bigger as we're kind of going around. So slowly, let's just kind of up like that. Then when we're over here, pi over 2 to pi, the y values are getting smaller, right? We're going down this way. So again, we're kind of slowly going down that way. So I'm just going to kind of curve it down a little bit. From pi, this is pi over here, to 3 pi over 2, the y values are going down towards -1. So here we're going to go down towards -1. And then we turn around and we head back up to y value of 0. So here we go, head back up, head over to 2 pi of a y value of 0. All right, so that's what the sine looks like if we start at the angle of theta and go around the circle 1 time. But that's not the whole graph of sine. That's just a piece of it. In fact, we call this one period of sine because we went all the way around. Now notice, if we kept going in the positive direction, this thing would just keep repeating itself over and over and over again. So I'm just going to kind of dotted line this, and this would just kind of keep going like that. And of course, it actually keep going this way as well. Going in that thing. So notice we kind of get this wave pattern. hence we generally call it a sine wave. The darkened in spot right here, this is generally the first period that we normally draw of that. But depending on what the argument is, this thing can be, like we saw in our transformations back in algebra, it can be shifted left, right, up, down, made it skinny or long, all kinds of stuff can happen to it, and we'll see that in just a minute. So this is what our basic sine thing looks like. Now, a couple of things that we want to notice, of course, it always goes to a max of 1, a minimum of -1, when we have a 1 out front. And the sine always starts on kind of this center line. We're going to call this our center axis here. It always starts on there, and in this case, normally heads up. Now, if we add stuff to it, it may head down, right? Remember, we can flip these things over. All right, let's take a quick look at cosine and do basically the exact same thing we just did. So let's get this out of here. I'm just going to change our table just a little bit and see what picture we get out of this. So instead of doing the sine, let's take a look at the cosine. Now, not much is going to change here with how we're going to handle this. The only difference is when we're looking at our unit circle, either this picture or this picture over here, remember the cosine is talking about the x values on this picture. So if we look over here at the angle of 0, the x value of that point is 1. So the cosine of 0 is 1. The cosine of pi over 2, excuse me, pi over 2 is straight up, so the x value of this point is 0. For looking over at pi, we're down this way, the x value of the point over here closest to me would be -1. When we're straight down, the x value of that point is 0, and of course all the way around we get back to 1. So I'm going to do the exact same picture I just did, well, not the exact same picture, but the exact same idea that I just did for that picture. And we're going to just kind of space this out. So we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's horrible. All right, so let's plot these points just like we did before. Now, the range of cosine is exactly the same. It's from -1 to 1, so we're going to go ahead and put those on there. Let's plot our points. When theta is 0, y is 1, so that's the point up here. Pi over 2, 0. Pi, -1. 3 pi over 2 is at 0, and 2 pi is at 1. All right, we get 5 points, but notice they're definitely spaced differently. But let's talk about what happens with the x values as we go around the circle now. Again, imagine going around the circle in this way. If I'm starting at this point, we start at an x value of 1. But as I head up here, the x value gets smaller and smaller and smaller and heads towards 0. So this slowly heads towards 0, so we're going to kind of round that out like that. Then we're at the x value of 0. Then the x value heads over to an x value of -1. So we're going to have this head down towards -1. Squeaky. All right, so then we're at this point over here. As we head back to 3 pi over 2, kind of down this way, the x value is going back to 0. So this has to head towards 0. Then when we're straight down and we head this way, the x value is increasing till we get over to an x value of 1. So that makes this graph increasing up like that. All right, so that's kind of one period of cosine. Because if you notice, if we keep going, notice we started up here and we're back up here. If we keep going, the graph kind of looks like this. That way, and if we wanted to keep it going that way, it looks like that. This is also a wave, so this can be called a cosine wave. Now notice, this actually looks exactly the same as a sine wave, just shifted over a little bit. Now the reason that that's true, and you don't need to write this down, is we saw a couple lectures ago that these are cofunctions, which means that one is just a shift of the other. Remember, back from our transformation sections in algebra, this is a type of shift that we can take a look at, shift and reflection. All right, so we can see here that the domain for both sine and cosine, since it's basically the same picture, goes left and right forever. The range goes from -1 to 1, so we're staying inside this little window. And they both have this nice wavy pattern. Now the big difference between sine and cosine is, notice sine normally starts on our center axis, the axis that runs right down the middle. However, cosine starts off the axis. Now again, depending on the other pieces with that, cosine's either going to start up here or down here. It could be reflected. Okay, so let's take a look at how to actually graph these when they're much more difficult than just a regular function. So we're going to do this in a multi-step procedure. What I mean by that is we're going to find out a whole bunch of information about the function first, then we're going to apply it and then draw a picture. So this works for things that have this form: a sine bx plus c plus d, or y is equal to a cosine bx plus c plus d. So notice the a, b, c, and d I've added in here to make this a much more complicated function. But all the a, b, c's, and d's do is different types of transformations that we learned way in the past. The easiest one to remember is, remember, if we just add a number to the end, all that does is shift the graph up and down. The a here out front is kind of like if I had the graph y equals x squared and said what is y equals 4x squared. That's just a multiple out front. That just makes a normal graph kind of skinnier. The bx plus c is a little bit more complicated, but remember, if we're adding something to the x, that's going to move your graph either left or right. And the b is also a scaling factor that kind of moves it this way as well. But we're going to see how all those kind of come into play. So the first thing, and this is, I'll show you the differences on each one of these. The a here, we're going to call the amplitude. Now, technically it's the absolute value of a, because a can be negative, but we're really just going to look at the number out front. The amplitude, that's going to tell us how far our graph goes up and down. Now remember, our graph normally goes up and down from -1 to 1. So if that's a 5 out there, it's going to go from -5 to +5, shift it up and down kind of thing. Now, in this case, if for the sine function, if a is greater than 0, we're going to say it goes up. If a is less than 0, goes down. You'll see what I mean by this in a second. It's a little confusing. Now here's the only difference between these two. Here, if a is greater than 0, this starts up. If a is less than 0, this starts down. Now for the rest of these, this is going to be exactly the same for either sine or cosine. This is the only difference, because remember, when we drew our sine function, sine started on the axis and started on the axis and started wiggling. However, cosine started off the axis and then started wiggling. So that's really the only difference. So it's either going to start by going up or going down, or it's going to start up or start down. That's what I mean by that. But again, we'll see an example of that. Okay, so that's our amplitude. The period. Well, the period of both sine and cosine is normally 2 pi. But this constant in here, b, that takes the graph and it squeezes it horizontally. So this way, either left or right, which means it's going to make our period either longer or shorter. So to figure out what the new period is going to be, you're going to take that period 2 pi and divide it by whatever that number is. And that'll tell you what your new period is. Now, we saw that it was very easy to graph both those functions with 5 points. So basically, we're going to have a starting point, and we want to take 4 steps to get to the end. So the step size is going to be whatever the period is, and we're going to cut that into 4 pieces. So the step size is the period divided by 4. That'll give us a place to start, and we step over our 4 steps, so it'll give us all 5 points for our period. Start, new end. Okay, for both of these, this plus c inside here has to do with a horizontal shift, either left or right, which means our original graphs, we started at 0 and went to 2 pi. So what does this stuff inside here do to what we normally do? Well, I should move that over a little bit. For our new start, all you do is you take the bx plus c, whatever that is, set it equal to where we normally start, where we started was 0. Your new end, well, take that bx plus c, set it equal to 2 pi. right? 0 and 2 pi is where we normally start and normally end. We know that that gives us one period of both sine and cosine. So that's a good place to say, okay, we're going to start. It's going to give us our new start and our new end once we shift it. And the last one, the easiest one, is the vertical shift is just that D out there. So basically, instead of what we generally would call the x-axis, our center line is going to be shifted by whatever this value of D is. All right, if you have to, pause and get all that copied, and then we're going to take a look at a couple of examples on how to graph sine and cosine. All right. So our directions for this is just going to be graph. Let's say I have y is equal to 2 sine, I don't know, x minus pi over 3. All right, taking a look at this, we generally want to go through and answer all the questions that we just did. So first, let's start with our amplitude. Now the number out front is going to say is 2. Since this is 2 is greater than 0, we know this goes up. The period is 2 pi divided by whatever's in front of that x. So in this case is 1, so our period is still 2 pi. Our step size is always the period divided by 4, so that's going to be pi over 2. Our new start, we take our argument, the x minus pi over 3, set it equal to 0 and solve. That's easy, just move that over, that's pi over 3. Our new end, we take that same argument, x minus pi over 3, and set it equal to 2 pi. All right, all we gotta do now is solve for whatever x is, so we add that to both sides, so 2 pi plus pi over 3. We need a common denominator, so this is 6 pi over 3 plus pi over 3, which gives me 7 pi over 3. Okay, our last thing we're gonna look for is a vertical shift. We don't have any number added out here at the end, so we do not have a vertical shift at all. Okay, so there's all of our information. We got that put over to the side. Now let's see if we can use all of that to help us graph this trig function. All right, so first thing you want to do is I'm going to draw my axis skewed to the right because I see I start at a positive x value and end at a positive x value. Now, since I'm not starting at 0, here's what you do. Pick a spot out here. That's where I'm going to start at. Go over some distance, ever how long you want your graph to be, put one there. Now, since we want 5 steps here to kind of make this look nice visually, you can just kind of stand back and say, okay, I'm going to cut that space in half. I didn't do a very good job. And then cut each one of those spaces in half. And that will be our 5 steps. And we'll figure out what those are in a second. Now, where's our center line at? Well, we didn't do any shifts, so our center line is right down the x-axis. So we'll be able to put our amplitude on now, because our amplitude always goes off that center line. So our amplitude is 2. So from the center line, we go up 2 and down 2. That's where our graph's going to fit in between. And we start at pi over 3. Okay, now before you put 7 pi over 3 out here, we're actually going to use that to check our arithmetic in a second. So what do we have to do to pi over 3? We have to add pi over 2 as we go across. So the idea, if I'm going to be adding pi over 2 each time, we need a common denominator. So what's the common denominator between pi over 2 and pi over 3? Well, that would be pi over 6, right? So I multiply the top and the bottom of this is 2, so this is 2 pi over 6. I'm just going to put that down there for right now. If I multiply the top and the bottom of this by 3, this would be 3 pi over 6. Okay, so let's see if this works out. So if I add 3 pi over 6 to 2 pi over 6, that gives me 5 pi over 6. If I add 3 pi over 6 to 5 pi over 6, that gives me 8 pi over 6. Now that'll reduce, right? That'll be 4 pi over 3. I'm just going to keep going. If I had another one, another 3 to that, that'll be 11 pi over 6. And if I had another 3 pi over 6, that gives me 14 pi over 6. Now, quick check, what does this one reduce to? That does reduce to 7 pi over 3. That's where we were supposed to end up, right? That's our end piece. So you can be pretty sure that you got all the numbers in the middle right. Now, generally you do want to reduce these. These two here will reduce, but not a big deal in this particular case. Okay, so we're almost done. That's almost our entire graph, believe it or not. All we have to do now is determine which function are we graphing, either sine or cosine, and which way does it go. All right, we're graphing sine, so we know it starts on the center axis. So we know at the first spot, it's going to be on the axis. Now what we got to do is say, does this graph start by heading up or start by heading down? Since the 2 was positive, we know the graph goes up. So all I got to do is put my points on there. It's going to go max, 0, min, 0. I'm just drawing a wave. Connect the points. And there you go. There is one period of our sine function. Now, if you're ever asked to graph 2 periods, all you got to do is just keep adding 3 pi, what do we say? Yeah, 3 pi over 6, another 4 times, and keep plotting the points, or subtract it 4 times, and you'll be able to get the entire graph. So by putting out all this information first, it makes it very easy to finally draw the picture. All right, let's take a look at maybe a cosine one. Maybe one that's a little bit more difficult. Let's say if we said -3 cosine 2x minus pi over 2 plus 1. All right, this is about as complicated as any of these are going to get that you're going to run into when we're first starting to graph these. So we got a lot going on here. So do me a favor, as you're sitting there working, pause this and see if you can fill out all the information that we're looking for. All right, you're back. Let's give this a shot. So our amplitude here is 3. Now you can call that -3 if you want to. Most books are going to be pretty much a stickler and say it's supposed to be the absolute value there, because the negatives gives us another piece of information. Since the -3 is less than 0, we know that this starts down. All right, our period is 2 pi divided by whatever's in front of the x, so 2, so our period is now just pi. Our step size is always the period divided by 4, so our step size is going to be, excuse me, pi over 4. Let's see where this thing's now going to start at and where it's going to end at. So our new start is we take our argument, 2 pi minus pi over 2, set it equal to 0. Our new end is going to be, I take the 2x minus pi over 2, set it equal to 2 pi. All right, and now we need to solve both of these. A couple of different ways you can do it. If you don't mind working with fractions, you can leave them in there. If you don't like working with fractions, remember you can clear these fractions immediately by multiplying everything by the least common denominator. I think a lot of people like doing it this way a little bit better, so I'm going to do it like this for you. 2 times 0. So I get 4 pi minus, x. There's an x right there. That's not a pi, it's an x. What am I doing? 4x minus pi is equal to 0. Move the pi over and divide by 4, so we get x is equal to pi over 4. Do the same thing over here. Let's clear these fractions. Pi over 2, 2 times 2 pi. So I get 4x minus pi is equal to 4 pi. Add pi to both sides, so 4x is equal to, what's that going to give me? 5 pi. Divide both sides by 4, so x is equal to 5 pi over 4. Okay, so we got a new start and a new end. Do we have a vertical shift? Vertical shift. We do, right? Because we have a number added out here on the end, so we're going to take our whole graph and shift it up by 1. I'll show you how we're going to do that in a second. All right, so if you pause the video and work on this, these are the values you should have got. Now with these, we should be able to do a quick sketch of this graph. Let's see. Since my start and my end are both positive, I'm going to shift the graph kind of over here to the right a bit. So I'm going to, that's really crooked. Try again. I'm going to shift the graph over here to the right a little bit, just so it's a little bit neater. Okay, so let's see, we're starting away from 0, so I'm just going to make a mark over here somewhere. Pick an ending spot, cut that in half, cut those in half, those are going to be my points. Now my vertical shift, we're going to take this whole thing and move it up 1. So generally I put, there's our 1 there. I put myself a little dotted line. Now this dotted line is not part of your graph, but it does kind of help you keep things visually in place. So from there, we're going to use our amplitude. So from 1, we're going to go up 3. 1, 2, 3. So this is up here at 4. And we're going to go down 1, 2, 3. So this is at -2. Okay, so notice from our center line, we go up 3, down 3. That's our amplitude. All right, let's put our values on our number line here. We're starting at pi over, what was it, pi over 4? We're starting at pi over 4, and our step size is pi over 4. So we already have a common denominator, so that's easy. So as I start at pi over 4, if I add another pi over 4, that'll be 2 pi over 4, which is of course pi over 2. Then 3 pi over 4. 4 pi over 4, which of course is just pi. Then 5 pi over 4. That's a little close. Let's move that out there a little bit. 5 pi over 4, and that's where we were supposed to end at, so that was a pretty good check. Okay, so here's our center line. So we already have our points, we have our amplitudes. Now we got to do is just plot this thing and we're done. So we got to know, are we graphing sine or cosine? We're graphing cosine. So I know cosine is going to start at the maximum or minimum, kind of top and the bottom, not on the line. So my first point's either going to be here or here, down here or up here. Well, which one's it going to be? Well, because it was negative, we start down. So my points there is at the lowest point, then it's 0. Now remember, 0 is now at our middle line here. Then 3 pi over 4 is going to be up, then back at 0, then down. Okay, so we're going to kind of try to draw this in a curvy way, because remember this thing's supposed to be a wave. And there we go. So remember, when you have a vertical shift, that's now your 0 line. That's where you will want to cross at those values. Now again, that is one period of our cosine curve. If you wanted you to draw more, you would just either keep adding pi over 4 that way or subtracting pi over 4 this way, and you would get more of kind of the wave pattern. Now, graphing sine and cosine is a nice little skill to have because it helps you visually see what's happening with the functions. And you're really going to need to be able to do this for graphing secant and cosecant. So before we get around to graphing secant and cosecant, I need to make sure that you guys can go do this. So go practice graphing sine and cosine, and when you come back, we'll learn how to graph all the other trig functions.